Hey there, welcome to the puzzles section of this course. Hopefully you took a look at the prerequisites and tried to solve those problems and got a good overview as to how loops work and how string manipulation and array manipulation works in Java. In this lesson, I want to go over the format for the puzzles section. There's basically going to be three parts. The first part is going to have simple programming problems with just a few lines of code where you get practice on applying your Boolean logic and simple string manipulation and some loops and array manipulation. In the second part, the problems are going to get slightly more advanced with some more code that you'll have to write to solve the problem, and it will require you to think a bit more abstract and logical in your problem solving abilities. And the third part is the more advanced stuff, where I go over some challenging problems, and we'll also cover some more recursion problems in that section. So what are these puzzles going to look like exactly? Well, they're going to be methods you have to write to solve a given problem. And in most cases, I'll give you an empty method signature with instructions. And your task will be to write the internal body or the guts of that method to solve the particular problem that's being asked. A lot of the puzzles that you'll be solving in this section are an inspiration from a website run by a Stanford instructor, and his name is Nick Parlante. It's a great online free resource called codingbat.com. And he's uploaded all kinds of free stuff there, some videos, some handy handouts that go over Java syntax of how to do loops and conditionals and so on. And then he also has uploaded some material for some of the courses that he teaches at Stanford. So if you're interested, you can definitely check it out. This is his homepage here. Just so you understand the format of these puzzles, let's take a look at a simple example I've already loaded here. Now, all assignments in the course will be downloadable, and this is just one example of the kind of format that you'll be seeing in the puzzles that you work on. And I've organized each of these puzzles into individual Java projects so you can download and complete the assignments in your editor of your choice. Now, all of the code that you'll have to work on in the puzzles section will be in the app class of every project. Okay, so every project is going to have a similar structure where there will be the assignment and then underscore number. So in this case, this is just an example. So I just wrote assignment n for number. And then in there's going to be two packages. There's going to be the assignment package, and then there's going to be the ignore package. You can ignore the ignore package, obviously, but feel free to look into what that does if you're interested. But anyway, let's open up this assignment n package, and there's this class called app.java. And similarly, you'll see the same type of class in other projects, and it's going to contain the main method here, which you can completely ignore. This is just sort of starts your program, but the majority of the work that you'll be doing is in this sort of section here. I'll provide a description of what this problem is supposed to do, and your job is to fill this body of this method so that the tests pass. If you put your cursor on the method name, it gives you these reader-friendly instructions. This method is supposed to add both parameters a and b together and subtract the number 3, and then return the result. And what the expectations are is when you run this method with two arguments, 2 and 5, what it's going to do is it's supposed to add these two together, so that's 7, and then subtract the number 3. So 7 minus 3 is 4. Okay? When you have 2 and 1, that's 3, minus 3 is going to be 0, and then 0 plus 2 is 2, minus 3 is negative 1. Okay? So these are the expected return values for these particular trials. Okay, and what your method should do is you should code this up in such a way that these tests pass. Now, there are some other tests, not just these are just sort of expectations, these are examples, but there are other tests that are in this ignore package, which you can completely ignore for now. Now, when I run this, let's hit this play button, that's going to run your program. Notice that when we pass a 2 and a 1, the test pass, you can see this pass. Same thing with 0 and 3, the test pass. It fails when we pass in a 7 and a 4, okay? Because 7 plus 4 is 11, minus 3. Obviously, we're just returning a 0 in every single situation here because I sort of left this stubbed out here for you to fill out. So this trial failed. It says that the expected is 8, so you want to make sure that you are able to code this so that all of these methods, all of these runs pass. So let's do that here, just so you can see this in action. And you can hit the play button here and notice that all of them are now passing. Okay, so that's the objective for every single project. Now you'll be surprised how complex some of these problems can get with just these simple loops and logic, and there's going to be some recursion coming on. Now there are a couple of more things that I want to cover before we end this lesson, and they're really going to be add-ons to what you've already learned in the prerequisite section. And this will give you more options in terms of how to solve certain problems. So let me close this class here. I'll just go ahead and close this project for now. And let's just create a new project. And I'm just going to call it sample project because it's just going to be a temporary thing in which I want to show you a few things. Just create a new class. We'll call it app, and we want the public static void main method in there. So just select that and then hit finish. And here's our class with the main method already defined in here. I want to go over something called the modulus operator. And it's available in pretty much all programming languages. This operation basically finds the remainder after division. So let's say we have the number 10, right? I'll define a variable called 10, and then I'll just assign it the integer 10, and then I'll have another variable called, let's say, 3, and I'll assign it the number 3. Okay? Now if I divide 10 by 3, 10 divided by 3, let's print out the value of that. Like so, let's hit the play button. Notice that it gives you 3. The reality is 10 divided by 3 is going to give you something like 3.333. But since we're using integer division, it basically drops the remainder and gives us 3. But if I was to use modulus here, which looks like this, a percent sign, and I hit the play button, it would give us the remainder, which is 1. So the way to think about this is 3 plus 3 plus 3 is equal to 9. What's left? 10 minus 9 is 1. 1 is the remainder. And in many programming problems, this operator is very useful. Let's say, for example, we want to identify all of the even numbers that occur in a series of numbers. So, for example, let me create an array here. It's going to be of type int, and I'll just call this variable numbers. And there's going to be 100 slots in there. And let's just populate this array. I is equal to 0, I is less than numbers dot length. Remember, that's going to give us 100, and I plus plus. And I'm just going to populate numbers with a sequence of numbers from 0 to 99. By the way, it's giving us an error, and can you figure out what the error is? Of course, we're missing the data type here for the I variable, and now everything should be fine. So we populated the numbers array with a series of numbers from 0 to 99, which is going to equal the length of 100. Now I want to loop over each one of those values, so you can use a shortcut. You can say int number, and then you can do this numbers. We saw this in the for loop section earlier. And for each number that is modulus 10, right, number modulus 10 is equal to 0, right? Let me just surround this with an if statement here. Right? If number, whatever the number is, modulus 10 is equal to 0, that means we don't have a remainder for dividing the number by 10. And in that case, if we don't have a remainder, it's going to give us a 0. That means we are finding a number that is a multiple of 10. So let me print out whatever that number is. Let's hit the play button and notice that it gives you 0, 10, 20, 30, 40, all the way up to 90. All right? And if I wanted to identify all even numbers, I would just do 2. Number modulus 2. If you divide those and there is no remainder, then that means that it is in fact an even number. So let's hit the play button, and now we get all of the even numbers from 0 all the way up to 98. Okay? And this way you can get multiples of different type of numbers. For example, let me get a multiple of 7. For every number that is a multiple of 7, it'll print out here. So hit the play button, and notice these are all divisible by the number 7. So this is a very useful method that you'll be using in solving certain kinds of problems. And when I assign you a problem that is going to need this operator, I'll give you a hint. I'll tell you that, hey, you have to use a modulus operator, at least in the beginning for the simple problems. And then once you use it a few times, you get a good idea as to when to use it. The next thing I want to talk about is related to strings. I should have actually covered this in the strings section, but since that lecture was already 19 or almost 20 minutes long, I decided to put that for later. And I think now, since we're about to start the puzzles, it's a good time for us to revisit that particular method that I want to cover regarding strings. So I'm just going to create another class here, and I'll call this class strings additional methods. Okay. And of course we need the public static void main here so that we can make this a runnable class. So let me create a variable of type string. I'll call it names, or let me just say sentence. Okay. And I'll say there is a small boat by the dock. All right. And I'll create another sentence. Two sentences here. There's a method called starts with. So I could do this. Sentence dot starts with. Okay? And with this method, you can check whether sentence starts with a particular word, for example. So let's say if it starts with there. Okay? So, and starts with is going to return a Boolean value, as you can see by the definition here. If it does find this word right in the beginning there, it's going to return a true, otherwise it's going to return a false. So let me surround this with a sysout statement so that you can actually see the result of what it found. So hit the play button here, and notice that it's false because sentence does not start with the word there because it's capital. There's a capital T there. So if I was to change this to with a capital T, hit the play button, of course it's showing true now, right? And there's an equivalent ends with method that is also very useful. And I can say, does it end with the word dock? And hit the play button, and of course it's saying true because sentence does in fact end with the word dock. Does sentence 2 end with dock? Well, it doesn't, so we expect to see a false. Hit play, it returns a false. Okay, so this is also a handy method for you to use in some of the exercises that you'll be seeing. Now, one more thing I wanted to cover is related to casting something that is not a string into a string variable. So for example, let's say we have an integer, age, and I'll say 29. And if I wanted to convert this into a string, I can use something like string dot value of. And if you actually press the control key and the spacebar, you'll see all of the different versions of value of. It can accept a Boolean, it can accept a car. These are all different data types that it supports. And over here it says that it supports an int as well. So I can just pass in age here, and it's going to return age as a string. So I'm just going to say age as string. Okay, I created a new variable, assigned it with age as a string, and now I could just print out age as string plus 27, for example, and you'll notice that it's actually age str, and you'll notice that 27 doesn't actually get mathematically added to 29. It actually just concatenates it with the string. So let's hit the play button and notice that this 29 here is actually a string, and then when I add the number 27, of course it just sort of appended that. It didn't actually mathematically add it. Now since sentence 2.ends with returned a false, right? So this returns a Boolean. I can convert this Boolean into a string value. So let me say, I'll just say str for this particular variable, and I'll say string.value of this content right here. So I'm just going to place that in here. So this is going to return a false, and that's basically going to be converted into a string. And then I can just print str here and hit the play button, and of course it printed false. Now in the print statement, whatever is in here, it tries its best to convert it into a string representation, even though this particular value here, whatever ends with returns, is going to be a Boolean type. But print line is smart enough to sort of convert that and present that to us in a string reader-friendly format. So in case you ever needed to convert numbers into strings, there's two ways of doing this. One is using string.valueOf, or you can actually just do plus and then add a little string there. And of course, since this is being assigned to an int variable, it's going to complain that, hey, type mismatch, cannot convert from string to int. So we have to change this to a string, and of course now it is compiling here, okay? So two ways of converting something to a string. One is using string.valueOf, right, and that returns the string representation of whatever you pass as the argument to this method. And the other option is to just plus empty quotes like this, and that will automatically convert that to a string. I like this approach better because it's more explicit. This seems sort of more hacky to me. That's why I sort of avoid it. But both options are open to you, and for the purposes of this course, in terms of solving the puzzles, it doesn't matter which approach you use. Whatever you're comfortable with, it's a matter of preference. Okay, so quick review. I just wanted to show you these sort of miscellaneous items that I wasn't able to fit in the previous lessons. One thing, back in the app class, we looked at how we can use the modulus operator. So modulus operator is used in division, and it returns a remainder. Whereas if you just do regular division, like that, that is actually going to return somewhat of a division, and it'll basically drop the remainder, okay? So 15 divided by 7 will actually give you a 2, even though it's slightly more than that. It's 2.12 or something like that, 2.2. But it's going to drop the remainder and return us a 2, whereas modulus would return a 1, because that is in fact the remainder of dividing, say, 15 by 7. Another way of thinking about this is you can subtract 7 from 15 and see how many times you can do that. 15 minus 7 minus 7, you do that twice, that leaves you with 14, and then the remainder is, of course, 1. Let's go over another example. Let's say we have 23 mod 10. Right? This is going to return a 3, because 23 minus 10 leaves you with 13, minus another 10 leaves you with 3. So that's the remainder, because we can't subtract 10 anymore. And that's an easier way of thinking about it. Okay, so hopefully this made sense. You should have enough knowledge now to solve all of the problems in the course. And everything that I've covered in the prerequisite sections, those are the only programming tools that you'll be using to solve the puzzles, okay? And in my solutions, I'm going to restrict to use only these things that I've covered, such as simple loops and conditionals and branching. There's no switch statements or anything like that. I wanted to explore only a subset of the Java language to solve some of these puzzles. So if you're already familiar with Java and you know how to use things like array lists and sets and maps, I restrict that. Don't use those things. Those things make it too easy. And by the end of the course, I want you to be in a position to implement your own utility maps and lists and so on. So you need to know how those things work, and you need to get to the granular components of programming and really improve your logic. And the only way you can do that is if you use the fundamental components of programming and really strengthen your abilities to solve these problems. Use these basic programming constructs to solve the problems, and these are the exact things that I'm going to be using in my solutions. So your arsenal is complete. All of the programming tools that I've covered in the past few lessons are available to you to use to solve the programming puzzles. I wish you the best of luck, and I'll see you in the coming lessons.